All right, we're good to go. All right, so moving on to the next page. So skipping ahead, we've got the example of marks achieved by a group of students plotted against the hours that they studied. So the relationship between the marks and the study hours can be linearized by either stretching the y-axis or compressing the x. So by stretching this one longer, by pulling this data up, or by pushing this data back across the x, we're going to get that type of transformation. Thus, the appropriate transformations are y squared log of x or 1 over x. And that will be backed up over here. Right, if we've got this type of thing, y squared log of x, 1 over x. Look at the scatter plot and evaluate the transformation has linearized the data. Choose the appropriate transformation, the highest results using the coefficient of determination. So this has gone ahead and done it for you, right? This is what our coefficient of determination is for y squared, for log x, and 1 over x. I'm just going to pause for a sec. Which one do you think is going to have the best linear effect? Which one has the highest r squared value? 1 over x. This one here was 0.93, so well done. Yeah, so this has the most linear data over any of these other ones. Just as a little side note, like we kind of did on the board, we would write this equation if our equation is y is equal to a plus bx. This one would be written as y squared equals a plus bx. This one would be written as y equals a plus b times the log of x. This one would be y is equal to a take b over take b over x. Cool. All right, so we're taking away in that situation to make room for the negative. That is all good. So the transfer data is linearized as scatter plot. Now can safely fit the least squares regression line. So we fit this regression line. It gives us this situation where we actually develop the equation, and that is all good to go off. Next page, you guys have got an actual question to do. Right, so first of all, we've got to determine on which way the data is heading. Where is it starting? Which direction is it going? Kind of starts here, works our way up. Just a different colour for this. And it goes like that. Right, so we're going to be using the same set of equation as last time. Right, the three transformations we would look at. We would look at a y squared, a log of x, or a 1 over x. So y squared log of x or 1 over x. And we've got to determine, to linearize the data, it would be best to the mathematical achievement against internet use, log of mathematical achievement against internet use, mathematical achievement against the log of internet use, the mathematical achievement against the internet use, or 1 over mathematical achievement against internet use, right? We've been given a bit of a confusing mouthful of words. We know that these three transformations would work, right? We know in our equation it's y equals a plus bx, right? And in this situation, our x is internet use. And our y is going to be the achievement, mathematical achievement. Right, so having a pause and looking at the three options, which one of these actually fits with the mathematical achievement being where the y is and the x being the internet use. In a situation like this, a really handy tip would be, well, we know that this is y, right? Mathematical achievement is y and the internet use is x. So we could just go through and go like, well, that's y and that's x. 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 Right, so this one here, we're not actually performing any transformation on, right? There's no transformation being applied, so it's not A. If I'm going to B, we've done the log of y. Log of x is one of the ones we're looking for, so that is also incorrect. If we go to C, we've done the log of x. That was one of our transformations, so it could be that. Let's double check. This one, we've done x squared, right? Y squared was an option, so it wasn't that. And this one, we've done the reciprocal of y, and that we're looking at the reciprocal of x over here, so it's not that one. it would indeed be C. So good job if you identified C. Moving on to this next one. So it's got the data in the scatter plot below shows the width in centimeters and the surface area in centimeters square of leaves sampled from 10 different trees. The scatter plot is nonlinear. To linearize the scatter plot, width squared is plotted against the least squares regression line and fitted to the linearized plot. The equation for the least squares regression line is width squared is equal to 1.8 plus 0.8 times the area. Using the equation, a leaf surface of 110 centimeters squared is predicted to have a width centimeters closest to. Have a bit of a pause, write out the full equation, right? And then we're looking at implementing centimeters squared. Is that going to be our area or is that going to be our width? Thinking about where it would fit in and having you go to write it in on your calculator. So pause the video. Let's see how we go. Yeah. So looking at the question, right? We know we can solve this side to a degree just by putting it in our calculator. We can do 1.8 plus 0.8 times 120, right? 0.8 times 120. If I did it on the calculator, it'd be able to come out. I think it's 97.8. Right? That is equal to width squared, right? Now, if you got 97.8 and you put D, you would have the incorrect answer, right? Because we haven't actually found out what width is. We've got width squared over here. So we need to undo that by finding the square root of both sides. So width squared, square root of width squared is just width, right? It cancels each other out. So then we're left with 97.8. The square root of that is width equals, should be something like 9.883. Yeah, perfect. So then if we look, we round that to 9.8. B is the correct answer. The red flag you should be looking for, if you're writing down width as 97.8 and width only goes up to 9 on our scatter plot, it should be pretty like in your faces. There's no way a width is. Imagine a width in centimeters of a meter long of a leaf from a tree. It's a pretty big leaf in terms of width, right? So we need to really have that concept locked in. I will write down on the back page. I'll write these down and I might just even send it out and you can print it out. Just how to undo these questions. So if you did it as a solve function, right, you wouldn't have to do that. If we just put this in our calculator as solve for width, right, or W, if that was just a W in there, it would spit it out as that 9.89. I'm just making sure you know there's that extra step involved.